Hello everyone, welcome to this lecture explaining what is a Hadamard gate with respect to quantum computing, what it is, what it does, how is it important. This lecture assumes that you have a little bit knowledge of circuits as respect to computer science, electronics, you know a little bit of what is a circuit. Because this one goes a little bit in a technical detail about what is a Hadamard gate, talk specifically about this one specific gate. Okay, so let's go ahead. What is a Hadamard gate? It's often denoted by the H symbol, as we saw in the previous one here, the H symbol. It works on a single qubit. Okay, it performs a fundamental operations in computer science, which is the most important function which gives the quantum computer its power, is it transforms that qubit in a superposition. Now, in regular computers, you have your regular bits, 32 bits, 64 bits, and each bit can either be in 0 or 1 state, right? It can either be on, which is 1, or off, which is 0 state. Now, superposition means it's called a qubit because it's a quantum bit. It means that it can be in multiple states at the same given time, at that same instant in time. That qubit could be in a multiple state or in multiple states. Okay, now here is a visualization in a block sphere, okay, wherein you have these three axes, x, y, and z, and you can see that the qubit can rotate in any direction. It could be in any direction. Okay, so it creates a superposition of the basis states. Okay, the basis states of either 0 or 1. So what is the superposition? It's a state in which a qubit can be in multiple states at the same given instant in time. Okay, and how does a qubit gets into a superposition is that you apply the Hadamard gate. You pass the qubit through this gate. So see, this 0 is going here, this 1 bit is going here. Now, what does it means is that once a Hadamard gate is applied to a qubit, or once a qubit is in a superposition, it is equally possible, or the probability of it being measured as 0 or 1 is equal, which means it has 50% chance of being 0 and 50% chance of being 1. Okay, now there's one major difference. When you apply or when you pass the bit 0, when the qubit initially when it is passed through the Hadamard gate is 0, it puts it in a positive phase. Okay, the qubit is in a positive phase, this one. When it is applied to 1, it puts the qubit in a negative phase. Okay, so either a plus state or a minus state. Okay, so mathematically this is how it's represented. It is often referred to as a plus state. So remember, when a qubit is 0 and passed through Hadamard gate, it's in a positive state with the equal probability of it being measured as 0 or 1. And when the Hadamard gate is applied on 1, it produces another type of equal superposition with a different phase, which is the negative phase or the minus state. Okay. One important characteristic of a Hadamard gate is that it's reversible. It has the capability of reversing the bit, which means if you apply to Hadamard gate subsequently, it will return the qubit back to its original position from where it started. Okay, they are reversible. So applying the Hadamard gate again to the qubit in the positive state will revert it back to its original 0 state. Okay, so here, if the qubit was in positive state after applying the Hadamard gate, if you apply it again, if you pass it through another gate, which is also the Hadamard gate, it will transform it back into its 0 phase. Now here it is, it's like a typical circuit diagram. Looks like a 1 bit applied to a Hadamard gate goes here, creates superposition, 0 bit passing through a Hadamard gate. So a typical circuit diagram doesn't not contain of just one gate, multiple gates. This is the controlled NOT or the C NOT gate. This is the flip gate, which will flip it. Flip. We're going to cover it later in the subsequent videos. What's a C NOT gate? What's a flip gate? But today, focus on the Hadamard gate. But this is just giving you an example of how a Hadamard gate looks like, or a circuit diagram rather looks like. This is the matrix representation of the Hadamard gate. Okay, so equal probability of 1 or 0. The negative phase if the bit was, if it was applied on a 1 bit, 1 qubit. Positive phase if it was applied to a 0 qubit. Now this is just a block sphere view, like how we saw the block sphere. This is 0 state, which is on the positive axis. This is the block sphere view if it's on the negative axis, if it was the one state. Okay, so it's in the negative region. This is in the positive region. It's just for visualization that you can visualize how the representation looks like. This is in a positive state. This is in a negative state. So what is the intuitive explanation? So let's say you're flipping a coin. Okay, the coin just goes flip. It has equal probability of heads or tails until you measure it. Okay, so as soon as even if your qubit, when it is applied to a qubit, a measurement gate is applied to a qubit, its superposition will collapse to either being 0 or 1. Okay, so upon observation only, we would know what it is, either heads or tails, with respect to a coin flip, or if it's a qubit, whether it's a 0 or 1. Now, the Hadamard gate is used in several different algorithms. See why it is important. Of course, it's created superposition, and superposition is the most fundamental factor that differences or differentiates a quantum computer from a regular your PCs or your laptops that you have. Okay, that's the most factor that distinguishes it. There are different quantum computer algorithms. We are not going to go in detail because this is about Hadamard gate and not about these algorithms. These algorithms we will cover in subsequent videos, but it is used in most of the quantum computing algorithms. Randomness, basic changes, okay? So, in summary, what is a Hadamard gate? It's a key tool in quantum computation due to its ability to create equal superpositions. Okay, it plays a critical role in many quantum algorithms, serves as the basic component of more complex operations. Okay, it is the ability to create superposition of states that it allows quantum computers to perform different calculations which are not possible or feasible using your regular compute or regular systems that you have at home. Okay, so this was in short what's a Hadamard gate. Let's test your knowledge, what you understood. So take your time, go through the questions, pause the video, see if you understand or do you know the answer to these questions. If not, go back and watch the video again. I will pause it for a minute. what will happen? What are the answers? All right, let's see the answers. So given a circuit that starts with a state of 1, okay, so the circuit is starting with a state of 1, and then you apply a Hadamard gate to it, okay, and then apply another Hadamard gate. So which means you are reversing. So it will go back to its original state. So in the first phase, when the qubit is 1, when you apply the Hadamard gate, it will be in a superposition. You apply it again, it will come back to its original position, which is 1. That is its ability to reverse. So in a quantum circuit diagram, how is a Hadamard gate represented? This is how in an H, whether you put it in a square box or put it in a circle. Okay, this is how it is represented. And you can see when it's applied to 0, it's in a positive phase. If it's applied to 1, it puts it in a negative phase, which we saw in the Bloch sphere. It's pointing to the North Pole or the South Pole. Now, if a qubit is initialized to 0 and passed through Hadamard gate, what will be the state of the qubit before it's measured? It will be in a superposition state. Okay. But since it's being, since the initial qubit was 0, it will be as a positive state. So if you measure the qubit in this question, what will be the outcome? Equal probability of it being 0 or 1, because that's the power of Hadamard gate, putting a qubit in a superposition. All right, thank you all for your time. Do watch this video again if you have any questions, any doubt, any suggestions. Welcome, comments, welcome. All right, thank you all.